Hi guys, I am Om Godge and today we'll be solving lab 4. So the first question was largest number. You are given n integers and you need to find so for each integer you need to pick the digit that is the maximum out of all these digits. So over here it's 4, over here it's 8, and over here it's 4. And then the first number will give you the first digit, the second number will give you the second digit, the third number will give you the third digit, so on and so forth. And then you have to print this big number at the end. Okay, so uh, let's say you have this number 4312, and you take this as input from the user, and then you have to iterate through each and every digit one by one. So first you'll go through this, then this, then this, then this, and oops, then this. So this was better. This. You already know how to iterate over these integers when you did the sum of digits question. So what you do is you take the modulo. Okay, you take this modulo 10 and that will give you the last digit, and then you can just do 4312 by 10, which will give you 431, and then you keep on doing this over and over. So you will put 431 over here, and then you'll get 1 over here, and then you will do this, and then you'll get 43, and then so on. You can get every single units digit, and then you just have to take the max out of all of these. So you can put a simple check that if the current number is bigger than the max number seen until now, then you update the max number seen until now, and you keep on going through this whole number. So at the end of this whole iteration, you'll have max until now set as the max number in this current number, and you will have another variable called x, which is storing the value of the answer. So what you will do is simply x into 10 plus max until now. So what this will do is okay, so at the start, so before the at the very start, x will be set to 0. So 0 into 10 will give you 0, and max until now in our case will be 4. So this will be 0 plus 4, which will give you 4. The next number that you have is 5, 6, 7, 8. So if you do 5, 6, 7, 8, the iterating it one by one and finding max until now, like I told you, writing a for loop over these and getting the remainders one by one karke, at the end you will get max until now as 8. I hope you can see that. And then you will come over here and then do x equals x into 10 plus max until now again. So this will now be 4 into 10 plus 8, which will give you 48. Now lastly you have 1, 2, 3, 4. So I'll just modify this. You have 1, 2, 3, 4. At the end you'll get max until now as 4 for this number, and then again you'll come over here and then just do x equals x into 10 plus max until now. You will get 48 into 10 plus 4, which will be 484, and this is your final answer. You have to return this answer from the function, I guess. Yeah. So you have to implement a function called give largest function, which takes in an integer n. It accepts n numbers, so this is just a simple for loop over the n numbers. Then it performs the computation and creates the number x and returns this finally. Okay, so I think this should have explained you what you have to code up. I'll show you the code directly now. Okay, anything else required? Alright, fine. So as they've told you, you have implemented a give largest function which takes in an integer n. You set an x to 0 at the start, and then you have a for loop going from 0 to n minus 1. You take the number as input and you have this max digit number. So what I said max until now is the same as max digit. So yeah, just this reading this. Yep, and over here as well. Okay, fine. Yeah, so you have max digit set to 0 at the start, and then you'll iterate over each of the digits one by one. So you will get the current digit by doing num percent 10, and you'll divide by 10 every single time to get the next digit. And if this digit is bigger than the max digit, then you will set max digit to digit. So at the end of this while loop, max digit will store the maximum digit in the number, and then you will just do x into 10 plus max digit as I explained over here. And after this for loop is over, you will finally return x to the main function. So the main function, it just accepts an integer n from the user and passes it to the function give largest and prints the final result. So you have an integer n, you see in n, and then you just call the function give largest and store it into result, and then you print result. Return 0, there's no need for this, but yeah, I'll just keep it for now. So that was it for question 1. Okay, now on to the second question. Rotate digits. You are given an integer n and a stream of characters as input, and each character can be one of the following: r, l, and x. So r does a rotate of the integer n one place to the right, l does one place to the left, and x ends the operations. Okay, so if you have this integer and you do an r operation, then 1 2 3 4 5 becomes 5 1 2 3 4. Okay, so you have 1 2 3 4 5, and let's say you read an r. So how do you convert this to 5 1 2 3 4? So first you need to find okay, so you already know that 1 2 3 4 5 percent 10 will give you 5. So extracting this last number is easy, and you also know that 1 2 3 4 5 by 10 will give you 1 2 3 4. So getting these numbers is easy. Now the question is how to so what you'll do now is you will need you will try to multiply 10 raised to something. Okay, it will be 10 raised to 5 plus 1 2 3 4. This will give you 5 1 2 3 4. Wait, my bad. 1 2 3 10 raised to 4. Okay, convince yourself of this, that if you multiply 10 raised to 4 to 5 and you add this number, then you'll get this number. So all you need to do is find this 4. This 4 is the same as the number of digits that are there in this number. So to find this, you can write a while loop at the start. So let's say your number is num. Okay, instead of a while loop I'll use a for loop. For int n equals num. Okay, not n. K equals num. K greater than 0. K divided by equals 10. And inside you will just do digits plus plus, and digits will be defined as 0 at the start. Okay, let me make this wider. Okay, so yeah, so num will be 1 2 3 4 5. So at the end of this code your digits will be equal to 5. So you can do 10 raised to 5 digits minus 1, and you will have num percent 10 over here plus num by 10. Okay, I hope this makes sense to you after I explained this. So num percent 10 is just the last digit of the number, and num by 10 is the first whatever digits that are there, except everything except the last digit that's over here. And then you multiply this with 10 raised to digits minus 1. Don't use this is the XOR operator in C++. Use the power function. So you can raise 10 to digits minus 1 and then multiply it with the last digit, and then you simply add num by 10 to your answer. And this is for r. Okay, so now you've calculated the r operation correctly. Now what do you do for the L operation? So for the left operation, 5 1 2 3 4 will become 1 2 3 4 5. Okay, so similar to this you will also require this for L. You will calculate digits as you did before, but now 5 1 2 3 4, you want to change this to 1 2 3 4 5. So what you'll do is 5 1 2 3 4 percent with 10 raised to 5. This will give you 1 2 3 4, and 5 1 2 3 4 divide by 10 raised to 5 will give you 5. Okay, my bad, 10 raised to 4. Convince yourself that this works. So okay, let me explain this. 5 1 2 3 4 1 1 2 3 4. So this is 10 raised to 4 and this is 5 1 2 3 4. When you take the remainder of these two numbers, you can multiply a 5 to this, so you get this number, and then 1 2 3 4 will be the remainder. And when you divide these two numbers, you will get the answer as 5.1234. But if you store it in an integer, then this part will go away and you will just be left with 5. So if these two numbers are stored in integers, then dividing these two numbers is the same as getting this number over here. So yeah, that's how you can get these two numbers. And once you've gotten these two numbers, you just have to do 1 2 3 4 multiplied by 10 plus 5, which will give you 1 2 3 4 5 as you wanted. Okay, so let's say you've gotten digits similarly as you got them over here for L as well. So your digits will be equal to 5. Then for L, what you'll do is, okay, you will have num percent pow. Okay, you will also have to use int over here. I forgot to mention that. Okay, so the power function by default returns a double value, and it will not work with a remainder operation directly because remainders are only applicable with integers. So before you actually calculate the remainder, you can typecast it to an int to avoid any issues. Okay, so you'll have power 10 raised to digits minus 1. um, okay, how do I close this? Okay, fine. And then this whole thing, 1 2 3. Okay, this whole thing will be multiplied by 10 plus you have num by int pow 10 digits minus 1 1 2 3. This closes this closes this closes this. Yep. So that is the formula for the calculation of L. The first part is just this what I've done over here. So you have num, you take the remainder of it with 10 raised to 4. This int had to be done because if you don't do this, it will return a double value and you cannot do the remainder operation with double values. So you can typecast it to an int first and then use this value, and then you multiply with the 10 to get to for this, and then to get the first number, you just divide num with 10 raised to 4 as we did over here. So this gives you the L operation, and for x you just need to break out. So for x, what do you want to do? Stop the operation. Okay, so okay, you're anyway. So for x, break out of the loop, and that's all. That's your whole program. Okay, so let's have a look at the code now. So alright, instead of using log 10 over here, we can calculate this for, okay, there we go. That's what I typed over here as well before. Yep. Num digits plus plus, and then you calculate the power once. So there was no typecasting required as I wrote over here because you're already storing it in an int, so it already does that over here by default. So you calculated power of num digits minus 1 because everywhere, like even for L and even for R, you are only using the power of digits minus 1. So you calculate it and store it over here. Okay, before I explain this, the rotate me function takes in two arguments, which is an integer n over here and a character. So the character is an operation, right? And then it performs the operations and returns the result. So the return type should be an int because it will return an integer and it will perform the operation inside. Okay, so if the operation is r, so the last digit is n%n, and then you just do last digit as I did over here, last digit into the power plus the remainder. So that's what it's done. You multiply last digit with the power and then you just add n by 10. Otherwise, if the operation was L, then you remove the first digit by dividing n with power. So this is the first digit over here, this part, and then you take the remainder of n with power. So the first part, remainder of n with power, multiply it with 10, and then add first digit in, and then you return the value of n from here. That is the rotate me function. And then in your main program, you accept an integer n uh, from the user. So there is an int n, you accept that int n over here, and the character op just keeps the operation. So ignore this for now. So you will do cn op, and while op is not equal to x, you will do this, and then cn op. Okay, you don't need this. All right, so you will take in the operation, and this loop will run until this operation is not equal to x. Is this required? No, I don't think so it is. Okay, alright, so if okay, you will take in the integer n, and then you will take in the operation, and then you check if the operation is not equal to x, then you will take, you will rotate the number with the provided operation and store it in n. So many students, what they did was they did not store this, they just called this function and assumed that n will get updated correctly, which doesn't happen, as you might have learned references. So only if you passed n with reference over here, only then will n get updated. Otherwise, if you don't pass it with reference, then you'll have to store it inside. You'll have to put an assignment statement over here. Yeah, that was something that some students made mistakes in. Okay, and then you take the next operation inside, and then you check whether the next operation is x or not, and then finally at the end you print out the value of n. Okay, so let me see if this works or not. S plus plus question 2, rotate digits, dot slash a dot out, 34172 RRRLX 72341. Okay, 9823 x 9823, and then 5347 LRLRLRX 5347. Okay, so yeah, that was it for this question. Okay, now on to the third question. Valid 2048 tile. So you might have played this game before. If you haven't, okay, I'll play the game for you all if you haven't played the game. Okay, so it starts. Okay, wow, I was playing this some other time. Start new game. Okay, so right now this is two twos, and I can press one of the four keys and make them move upar niche. So the objective is to merge similar numbers together. So like right now I merged two fours to an 8. Now I'll merge these two to a 4. So that's the objective of the game. You have to make as many pairs as possible. Yeah, it's a very fun game. Okay, let's see. Mm, okay, okay. Um, Alright, I'll stop now. Otherwise, I'll get too distracted. Okay, so that is the game, And as you saw, okay, wait, as you saw, all of these values, they are powers of 2. So in this question, what you have to do is just figure out, well, which you'll be given a number n, and you have to check whether it's a power of 2 or not. So is it a valid tile in that game or not? That's what you have to do, and you have to write this in a function. So they have told you to use bitwise and shift operators, and not to use anything else. Okay, so I'll explain you the easy solution first and then the tough one. So let's say you have any number 2 raised to k, let's say 5 for now. So 2 raised to 5 in binary will just be 1 and 1, 2, 3, 4, 5. It will just be this. Why will it be this? Okay, so let's say you have 10 raised to 5 in decimal. So in decimal, 10 raised to 5 is simply 1 with 5 zeros, right? 1, 2, 3, 4, 5. Okay, even this will have 5 zeros, my bad. Yeah, this is because each digit can hold 9 values. Each digit can hold 10 values. That is why 10 raised to 5 is 1 with 5 zeros in decimal. Similarly, for binary numbers, since one digit can only hold 2 values, 2 raised to 5 is 1 with 5 zeros. If you don't believe me, just try calculating it on your own and convince yourself that any 2 raised to k power will just be 1 with uh, 1 with k zeros behind it. Oops. Behind. Okay, so now that you know that a valid tile will only have a single one and all other zeros, the simplest thing that you can do is, okay, let me, you can do while n greater than 0. So what you can do is simply count the number of ones that will appear in the binary form of n, right? So if n and 1, um, uh, count ones plus equals 1, and then n divided by 2. Okay, and before this you will set count ones to 0. Okay, so I'll explain what I've written over here. Let's say your n is a number 6. So 6 in binary is just 110. Okay, so this number has 2 ones, and as you know, this is not a valid tile. So what this program will do is it will count the number of ones that are there in the binary form of 6. So first you have count ones, which will store the count of ones as 0, and then this loop will run while n is greater than 0, and it will divide by 2 each time. So what does this division by 2 actually do? So you have this number, when you divide this by 2, you will just get rid of the last digit and you'll be left with 11. Um, this is the same thing that happens with decimal numbers when you divide with a 10. So when you divide a decimal number with 10, you get rid of the last digit and you're left with the rest. So similarly for binary, when you divide with a 2, you're left with the rest of the number. Alright, and then you can keep on doing this until it goes to 0, and when it goes to 0 you break out of this loop. Okay, so now with this number, what do you do? you take the bitwise AND with 1. So when you do 1 1 and 1, you get a 1. Okay, I missed the first one. So first you have 1 1 0. When you take the bitwise AND of 1 1 0 and 1, you can assume that you are taking the bitwise AND of these two numbers. So 0 and 1 will give you a 0. 0 and 1 again gives you a 0, and lastly 0 and 1 will again give you a 0. So um, taking the bitwise AND with a 1 just checks if the last bit over here is 0 or 1, because the rest are all zeros, right? So all of these will evaluate to 0 always, but if the last bit is 1, as it is over here, it gives you a 1. Otherwise, in all other cases where this is 0, it will always give you a 0. So what we are doing over here is that we are checking if the bit at the units place is 1 or not. Okay, so for 11 over here, the bit at the units place is a 1. So whenever we encounter that, we just increment count ones by plus 1, and then we get rid of this bit and keep on doing this for all the bits that are there in the number. Okay. Since they have told you to not use um, other operators and use bit shift operators, instead of dividing this by 2, what you can do is bit shift this to the right by 1, which is the same as getting rid of this number. So okay, when you do this, you will get rid of this bit and move all the bits to the right, so you will be left with this, which is the same as 110 by 2. This will also give you the same answer. Yeah, so this is the easiest solution. So at the end, what you can do is return count ones equal to 1. So if count ones is equal to 1, then you have only 1 1 in your whole binary, in your whole n, like in its binary form, and so it is a valid tile, and you will return a true. If the count ones is not 1, which means either it is bigger or it is 0, in that case this will return false, which is the right case, which is it's not a valid tile, that's why it return a false. Okay, so this was one solution that you could have thought of. Okay, ignore this for now. So you'll have bool is valid tile. The reason why we are taking unsigned ints is because the restrictions that are given over here is up to 2 raised to 31. So even over here I have given a hint that you should use unsigned numbers. It's because when you're dealing, so integers, the max integer that you can store is 2 raised to 31 minus 1. You cannot store 2 raised to 31 inside a normal integer, and that's the reason why you're using unsigned integers over here. Okay, so unsigned int n. Okay, let me alright, wow, one sec. Okay, never mind. Ignore this, whatever is coming for now. Okay, you have int count ones equals 0, and then while n greater than 0, and left shifted by 1, right shifted by 1, my bad, and then you have if n and 1 counts plus plus, and then you do return count 1 equals 0. So this will work as you want it to. but still this code is slightly bigger, so there is a better way to do it, which is this code over here. Alright, okay, so I'll have to explain this first. Okay, so why is this not going? Okay, you have a number n, let's say it's 7 for now. Okay, let's just start with a power of 2. Let's say this number is a power of 2. So what n is basically 1 with k zeros. Let's just say it's 5 for now. Okay, I wanted this in a different, okay, never mind. So in this case, notice that n minus 1 will be 5 ones, 1 2 3 4 5. Yeah, n minus 1 in the binary form will be 5 ones, and there is a 0 over here. Okay, so when you take the bitwise AND of this number and this number, you see 0 and 1 AND will give you 0, this 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 will give you 0, and finally this will also give you 0. So the bitwise AND of n and n minus 1 will be 0 if n is a power of 2. Okay, and let's say if n isn't a power of 2, so n is n has more than 1 bit as 1. So in that case, let's say this is the number, or let's just take two bits, right? In this case, okay, let me take this. Alright, so let's say your n is this, and then your n minus 1 will be 1 0 0 1 1 1. So what you notice is that this, the most significant one, will remain, and when you do taking the bitwise AND of these will result in a non-zero value. Okay. Alright, so as long as n has more than 1 bit as 1, when you calculate n minus 1, you can there will be at least 1 bit which remains unchanged in both the numbers. How do I explain this? So just try to think about it intuitively. Since there is 1 1 over here, okay, I think I found a way. So let's say that there is one most significant bit which is 1, and then there will be some 1 over here somewhere, right? Some 1 will be there because there is more than 1 bit. So when you calculate n minus 1, this, the most significant bit, will remain unchanged. It will not change. It will remain as it is in this number as well. And this, the rest of the stuff will change. So this will become 1 1 1 1, which is fine. This, the most significant one, stays unchanged in n and n minus 1. And so whenever you take the bitwise AND of both of these, the bitwise AND of this will give you a 1, and the rest, I don't know, the rest might be anything. So this will always result in a non-zero value. Only in the case of 2 raised to k, or when there is only a single one, the most significant bit is changed to 0 and all the others become a 1. So it becomes the exact opposite, and when you take the bitwise AND of both of these numbers, you end up getting a 0. This only happens when there is a single one in the binary form. and that it gives you a 0. Okay, I think this should explain it. So over here we have assumed that n has more than one bit. It can have less than one bit as well, which is a special case. So uh, if n is 0, if n is 0, then it has no ones in it, and so this case is handled separately. That's all. Okay, so now we can understand the code and what it's doing. So you have a function called isValidTile, similar to the one that you had over here, and you return n greater than 0 and n and n minus 1 equal to 0. So this is what we just saw right now. Only for valid tiles will the bitwise and be equal to 0. So if the bitwise and of n and n minus 1 gives you a 0, that means it could be a valid tile, and you have to make sure that n is greater than 0. If n is equal to 0, then this will always be 0, so you will mess up. So this is important. So this makes sure that n is not 0, and that there is at least one bit 1 in the number n, and then you check if is there only one bit which is 1, or are there more bits which are 1, and then if this becomes 0, then you return true, otherwise you return false. So this was a better way of solving the question. So yeah, that's question 3 done. Question 4. Alright, there is some guy named Om as well over here. Om is working on creating an LLM that would match the latest Chinese model shallow hide. Okay, with fewer resources, and he wants your help to tell him whether two words are anagrams or not. Okay. So I hope you understand what anagrams are. Anagram is basically two words which have the same letters but in different positions, or in the same position as well. So you need to check whether these two words have the same letters or not. Yeah, that's what you have to do. The one way to do it is to count the occurrences of every letter, and then just see whether all the letters are matching or not, like the counts are the same or not in both the words. But since there are 26 letters, and over here in this question you also have to take care of uppercase and lowercase letters, there might be 52 variables that you'll have to store, and that will become too difficult for you to handle. So then this Mr. Om has gone ahead and given you an algorithm to solve. So nice of him. And he explains you how you can find anagrams. So you have to write a function is anagram that takes in the length of two strings m and n, as I have done over here, and they check if they are anagrams and return a bool. So you return a bool based on whether they are anagrams or not. Okay, and if m is not equal to n, which means the number of letters are not the same, so they can never be anagrams, because if the number of letters are not the same, then you cannot shift the letters to make the other word, right? You'll need the same number of letters at least. So yeah, that's it. So your function is anagram should do the following: it should input m characters for string 1. So that's what my function does. So okay, wait, before that I'll explain this later on. So you have to take long for the products, not for the sums. I just wrote it in one line, that's why I've written sums as long as well, but you need the product as long, because the product of values might exceed the integer upper limit. So in this case m and n are between 1 to 9. So in ASCII encoding, a character can have a maximum value of 127. So you can have, oh sorry, a character can have a maximum size of 127. It goes from minus 128 to 127, right? So you can have minus 127 raised to 9 as the maximum product of all the numbers. So I'm assuming that each single um, letter in the word was a character which had the value of 127. So 127 raised to 9 approximates roughly to 2 raised to 63. So this is how big the product can blow up to. But your integers can only store values up to 2 raised to 31 minus 1. So you'll need extra space. So for that, you have to use long longs to store the product. When you use long longs, you get 64 bits of precision, 64 bits to store the value, and so the maximum number that you can store is 2 raised to 63 minus 1. So this is a rough estimate, right? So this, it will never reach this number exactly. That's why this works out. Okay, so you input m characters one by one. So there's a loop for m, and you take in the character, and then if the character is uppercase, you convert it to lowercase. So if the character, the ASCII value is bigger than a, then you convert it to, okay, wait, alright, I have done the opposite over here, my bad. So I have converted the character to a lowercase, to an uppercase. Wait, I'll just change the code. If character is greater than equal to a, and then character is less than equal to, okay, similarly over here, okay, fine. So if the character is an uppercase letter, then I convert it to lowercase. You have seen this before. And then find the sum and the product of the ASCII values for string 1. So this is not required over here. So you'll find the sum, and you'll just add the sum, add the character to the sum, and you'll multiply it to the product, and you'll do the same for the other number as well. And at the end, you will check if m is not equal to n, you will simply return a false. Otherwise, you will check that both the sums are equal and both the products should also be equal. So this is a condition that is required for anagrams to exist. Why this condition works and why does it give you anagrams, it might be out of the scope of this course for now. So just assume that this, whatever Mr. Ohm has written is right, and just follow through the algorithm given to get the answer. Okay, so this is your is anagram procedure as was explained over here. Okay, now to the main program. The main program takes an input, a number t. So you take input as t, and then you loop over t times, which is this while t minus minus. Okay, so this is just a simpler way to write a for loop. So you could also write this over here. This is just a simpler way of writing this, because you don't really need the value of I inside here, right? You just need to loop t times. This is the same as writing repeat t. Writing while t minus minus is the same as writing repeat t. The reason is because as long as t minus minus is greater than 0, you will keep on looping through this, and when t goes to 0, you will break out. This condition will be false, and then you will break out of it. So this will repeat exactly t times. That's why this works. Okay, alright, and then you take as input two integers m and n, and then you just call the function and print if it's an anagram. If it's an anagram, you print a 1, otherwise you print a 0. So you just do cout is anagram mn, and then you'll get the answer. So yeah, that was it for this question. Okay, now on to the fifth question, anagram. So this is similar to the last question, except that there are numbers instead of strings. So similar to the last question where you had kept a um, count, like you're matching sums and products, right? So you could use the same algorithm over here as well, and it will work. So you could just find the sum of all the digits and the product of all the digits and make sure that they match at the end. And you'll have to make sure that the length of these numbers are the same. So to find the length, you could directly do this. Length of a will simply be log 10 of a plus 1. This will give you 5. So for this number, it will give you 5. The reason why it gives you 5 is because 1, 2, 3, 4, 5. You can write this as 1.2345 into 10 raised to 4. And then if you take log 10 of this will give you log 10 of this, which will then further give you this, which will then give you this, and this value will be between 0 and 1 because because log 10 of 1 is 0 and log 10 of 10 is 1. Because of these two reasons, this value will be between 0 and 1, and this is 4. So when you store it into an int, this value is gone, it is thrown away, and you're only left with a 4. So that's why you add a 1 baad mein to make sure that you account for all the digits. So that's why you do 4 plus 1, which will give you 5, which will give you the length of this particular number. Okay, this is a fast way of doing it. Otherwise you can also write a while loop or a for loop as I did before in the same tutorial. Okay. Yeah, you can find the sum and the product of the digits and make sure that the lengths are the same. You can solve it that way. Another solution for this question is to keep 10 variables, and okay, so you'll have 10 different variables keeping the count of a particular number. So count 0 stores how many times did 0 come in a number, then count 1 stores how many times did 1 come in the number, and so on. So you will write a while loop. While a greater than 0, you will extract a digit by doing a %10, then you write a switch case on cur. So if case 0, which means if cur was 0, then you do count 0 plus plus, otherwise you do count 1 plus plus, count 2 plus plus, and so on. And okay, did I forget to add this? You'll have to do a by 10 over here, my bad. Okay, so yeah, you will keep on looping through this and increment all of the counts. So the counts will store the particular counts for a. Now for b, instead of adding into another thing, you can subtract the counts of a. So you will subtract how many ever times 0 comes, and how many ever times 1 comes, and so on. And if they were perfect anagrams, then all these variables will become 0 at the end. If a and b were anagrams, then the number of times a digit occurs will be the same in both of them. So this guy adds them and this guy subtracts them, so in the end they will be 0. So if all of these variables at the end are 0, if count 0 to count 9 are all 0, then they are anagrams, otherwise they are not anagrams. If this is negative or if this is positive, then they are not anagrams. So yeah, that was one way of solving this question. The other is to calculate sum and products, as I told you. Okay, yeah, that was it for this question. Okay, so the sixth question was given for fun. So liar's bar. Okay, so I made this question, and liar's bar is a video game, and there's this video which you can see to understand what.
Toast never loses. How? Why and how?
Wait, you're both pigs?
I am not watching this video. You can see the first 5 minutes of the video, I guess.
Queen.
Not even 5.
Bullet. If they claim you're lying and you're telling the truth, they then must point the gun at themselves. And you keep going until only one person remains alive.
Okay, so you can watch the first 2 minutes of this video to get an idea of how the game is. And then this is just a toy version of the game. So yeah, I have implemented the whole game over here. Yeah, you can go through other comments are self-explanatory. Try to understand this code and play around with it and have fun. This is just one way that you'll see games being made in C++. So yeah, that's all. Just try running this code and playing with it. That was all in this question. Okay, yeah, that's all for question 6. Okay, now coming to the 7th question, which was decoding cipher. Okay, so you are given a string and it contains a mix of encoded cipher types, and there are 3 different types of ciphers. So the first type is just mapping 1 to A, 2 to B, and 26 to Z. So okay, I'll just start one by one karke. So let's just assume that there is a function which is called handle type 1, and what it does is it will take an input, a number. So for type 1 there is just one number as input, so it will take the number as input, whatever it is, and then you will subtract 1 from this and add capital A to it. So we subtract 1 because A से start हो रहा है, so you're starting from A, that's why you are basically mapping 0 to capital A and 1 to capital B and so on, instead of 1 to capital A. Okay, I think I'm making this worse. Think of it this way, that num minus 1 gives you the offset that you have. So if you're starting with A, the offset will be 0. Then if you want a B, then the offset will be 1. If you want a Z, then the offset will be 25. That's why you're doing a minus 1 over here. And you have to convert this to a character. You could also do this instead, which is char C is equal to this, and then just print C over here. This also works, but I wanted to write it in a single line, that's why I did this. This will give you a number, and then you convert that number into a character and you print it out on the screen. This is type 1 cipher. So assume that this is a function that is made for now. Now before going to type 2, let's understand type 3. So type 3, in type 3 you'll have 2 inputs. One is a digit and one is a letter, and you just have to repeat that letter the number of times. So the handle 3 function has a character and a number, and you take both of them as inputs, and then this is just a fancy way to write for loop, as I explained before in the video. So you loop over n times and you print that particular character. Yeah, this this is the same as writing repeat num. Okay, I have explained this in the video previously. I don't remember which question it was, so just rewind it a little bit and see if you skipped the video in between. Okay, so this was type 3 cipher. Now let's understand what type 2 cipher should do. So in the type 2 cipher, the character is shifted by a constant amount k. So you are given a character and an integer k, and you need to shift it back by k positions. So they've given an example that if k equals 3 and you have a, it becomes x, and b becomes y. So okay, let's say that your character was a, and for k equals 1 you'll get answer as z. Then for k equals 2 you will get y, for k equals 3 you will get x, and so on. 4 you will get w, and 5 you will get v, and so on. So the first thing you should notice is that when k becomes 26, you will go back to a, and then 27 per you will go back to z, and so on. So after let's say you write k as 26 into a plus b, where b is less than 26, right? So all of these k's are useless, so this all of these ones will just bring a back to itself. Okay, I think that might be too much, so let's just say 26 into 2. Okay, let's say you have k as 26 into 2, and if you do 53 shifts of this, it will 52 shifts of this, it will bring you back to a, because the first 26 shifts will bring it back to a, and then the next 26 shifts will again bring it back to a. So any number over here will always bring it back to a itself, so this is useless. So everything over here is useless. All you need is b, where b is less than 26. So how do you get this b? It's simple. Whenever you just use k percent 26, so taking the remainder of k with 26 will give you a number which belongs between 0 and 25, and these are the only shifts that you need to care about. Every other shift will be every other like every this every a into 26 shifts will bring it back to a itself. So you don't need to care about all those shifts, you only need to care about the last the last part that is there, so the remainder that is there with 26. That is the only thing that you need to worry about. All the other shifts are useless. Okay. Alright, I hope that made sense. So now we'll assume that k is a number which is less than 26, because if it is bigger, we can always get rid of 26 moves, as it brings CHR back to itself. So if so, we can just write k equals k percent 26, and this will ensure that k stays less than 26. Okay, so For now k is less than 26. So now what you do, ahead of this you just take a and you subtract k from this. Okay, before that, my bad. You have your character chr, you subtract a from this. So for now a, this is a, so this will give you a 0. Let's say you had an h, so h will give you a b c d e f g h. H will give you a 7 over here. So it just denotes what position is it in the alphabet, and then to this you subtract k from this. This will give you your new letter position. So you found the position of that particular letter in the alphabet, and you subtracted k to move it back by k times. And you might have noticed that this number can go negative. So if new letter pos is less than 0, then you add 26 to this. The reason why you can add 26 is because as I just told you, making 26 extra moves doesn't change the character itself. So since this was negative and I did not want to deal with negative numbers, I can simply add a 26 to make it positive. Once I've done this, then I'll just do cout a plus new letter pos, and I'll have to convert this to a char or a character. And this is your whole code. This is the whole logic for type 2 cipher. So let's see the function now. I have written a lot of comments over here for you guys to understand it. So if the video solution wasn't clear, try to read through this. This will hopefully make it more easier for you to understand. So handle type 2 function, what it does is it takes in a character and a number, and so number over here is just k. So you just do k equals k percent 26 as I told you over here, and then you find that. So I used a new integer called new letter pos, but I'm reusing num over here. So I store chr minus a minus num, as I told over here, into a variable. So I reuse num over here, and then if num is less than 0, I just add 26 and then I print out a plus num. Those are the 3 types of cipher. Then in your main program, you will take in an input n, which is the number of test cases that you have, the number of encoding operations, and then you loop over n times. You take in the type, which is inputted over here on each line, and then there's a switch case on the type. So if it is a case 1, then you call the handle type 1 function, otherwise you call the handle type 2 function, otherwise you call the handle type 3 function, and then these functions will handle themselves accordingly. And if you enter something wrong, then this will be printed out, which will never happen for the test cases that are provided on both the trees, so you can relax about this. Yeah, that was all for this question. Okay, the letters are always capitalized, so you don't need to worry about other issues that can happen. Yep, that's all for this question. Okay, now for the last question, n triangles. So in this question, you are given a number n, which denotes the height of the triangles, and then you have to print 3 triangles with that particular height. To solve this, you have to make a function called print starry line, which takes in two parameters, which are num stars and num spaces, and returns void. Okay, so the way to solve this question was that this will be your num spaces and this will be your num stars. So inside your print starry line, you will print this particular line, and then you will call this function n times in your main program. So and you will calculate the number of spaces and the number of stars on every line inside your main program. Okay, so you can see easily that the number of stars, not the total number of stars, the number of stars in one triangle, they get incremented by 2 in each line. So you start from 1, then you have 3, then you have 5, and so on as well. You will have the number of stars being incremented by 2 each time, okay, in every line. And the number of spaces, over here there are 2 spaces, which is the height minus 1. So n minus 1 spaces on the first line. Then over here you have just one space. So the spaces are getting reduced by 1, and the number of stars are getting incremented by 2. So this should give you an idea of how you would write the main program. So here is the main program. You have an integer n, you take it as input, and then spaces start from n minus 1 and star starts from 1, and then there's a for loop, and you print this line, then you increment star by 2 and space you decrement space by 1. Okay, I'll just make this while n minus minus. Okay, so yeah, this is how your main function should look like, and I think this makes sense. So now printing the starry line will come inside this function over here. So you have gotten the space and the star. So between two triangles there is one extra space over here. So the between two triangles there is number of spaces, and one extra space over here. So you have to account for this when you're printing out the pattern. So there is a for loop which runs 3 times. This is to print each single triangle one by one. So first you print you print space amount of spaces. So you print these amount of spaces. I'll just make this num spaces so that it becomes easier to understand. Num space this, and I'll make this num stars. Okay, yeah, so this prints the initial spaces over here, and then this for loop prints the number of stars. Okay, yeah, so if the last this is just checking if we are printing the last triangle or not. So if it is not the last triangle, then we will have to add these spaces over here. Oh my bad, we will have to add these spaces over here, which is just number of spaces plus 1. So that's why this is being done. So this prints out number of spaces plus 1 spaces, and then this will print the line from here to here. Oh, oops, my bad, here to here. Then you will loop through this and you will go over here again, and then you will print num spaces over here again. So that will print out these spaces 1 2, and then you will print the stars, and then you will print these spaces again, and then the last time you will just print the spaces and the star. You will not print any more spaces over here because this will give you false. And then you continue this for each and every line and calling this function correctly. So this gives you the required pattern drawn. Yeah, that was it for this question. Okay, this might come in your lab quiz 1, so yeah, all the best for that. and that is the end of lab 4. So yeah, thank you.